Six Sigma is a methodology. Six Sigma is a methodology to reduce defects by reducing the process variation. So what will happen? This will improve the performance on the CTQs that are going to come out from the process, right? So there are two methodology, DMAC, another one is DMADV. DMAC is to facelift an existing product, improve the quality of an existing product. We are trying to cure a disease. DMADV, we are developing a new product. It is a birth-giving process. We wanted to be sure that the child that is going to born is completely disease-free, isn't it? So that is DMADV, a new product development. This methodology is also known as design for Six Sigma. And now let us understand the statistical aspect of Six Sigma with an example. Imagine a company, a call taxi hiring company, right? Like Ola or Uber or something. And now what is the customer requirement here? What will be the customer requirement? As a customer, when you book a car using the app, you expect the car to arrive according to the targeted time, isn't it? The targeted time will be indicated by the app itself. Hope all of you agree with me. Imagine, let us analyze a situation where cars are expected to arrive in 20 minutes. Now, what is the challenge now? The call taxi company should ensure sufficient number of cars are available in a particular locality with properly trained drivers, with very good car condition, and with a very good mobile app, which can correctly estimate the arrival time of the car whenever a car is booked in that locality, right? And in a particular pin code, when a car is booked, the app is showing the arrival time as 20 minutes. So customer will think that car will arrive in 10 minutes. So the customer targeted arrival time is 20 minutes. Hope all of you understand my explanation. At the same time, due to some challenges on the way, isn't it? Always there will be tolerance. Your customer is ready to tolerate for a plus or minus 10 minutes. Though the app says car will arrive in 20 minutes, plus or minus 10 minutes is a tolerable limit, right? Maybe if you really wanted to delight your customer by always delivering the car within the app estimated targeted time of 20 minutes, then we will probably redesign the process. But right now let us assume customer will tolerate plus or minus 10. So what is the upper spec here? 30 minutes. What is the lower spec here? 10 minutes. If the car arrives anytime between 10 minutes and 30 minutes, customer will be happy. Or otherwise, you can understand this manner. Whenever a customer expects the car to be within 30 minutes, it is a one-sided process. When the car doesn't arrive within 30 minutes, customer will cancel the order. If it arrives before 30 minutes, it is always accepted. So it's a one-sided process. But for our requirement, now we are going to change the requirements. Customer targeted time is 30 minutes, but we will design the process like this, 20 plus or minus 10. That means we are designing the process in a way that always the car will arrive in 20 minutes. Even in worst case, car will arrive within 30 minutes. In the best case, car will arrive in 10 minutes. Now, what is the upper spec? 30 minutes. What is the lower spec? 10 minutes. I'm going to, if every time a booking is done, if the car arrives within this specification limit, your process is considered capable, right? I'm visualizing this. Upper spec is 30 minutes, lower spec is 10 minutes. Customer targeted arrival time is 20 minutes. The total range is called specification width. Higher value minus lower value is 20 minutes is the customer tolerance. 10 on the right side, 10 on the left side, which is also called as specification width. Hope this diagram is understood. Now I want to measure my current capability. In order to measure my current capability, the past performance data, a sample of 100 data, that means 100 car deliveries, happened in that particular pin code. The data is picked up. Now I have arrival time of 100, car deliveries. So 100 data available. With 100 data, I calculate average. That average is X bar. X bar is calculated to be 20. What is the customer targeted value? Customer targeted arrival time, that is also 20. What is the average of your data? That is also 20. It simply means you are holding the gun correctly. It simply means you have captured the customer requirement and designed the process in line with the customer requirement. The process is designed carefully and correctly. And that is what your X bar is telling. Now you can actually expect your car to reach the customer place in 20 minutes, which is, this is called, voice of the process. From the process, I collected data, calculated the average, and that average is on the target. Though average is on target, it doesn't mean that every time the car is arriving in exactly 20 minutes. No, plus or minus. So in order to know that uncertainty, I measure the standard deviation using the 100 data. You just now we learned the formula, right? I'll use the formula and standard deviation is found to be 3.33. And now locate your control limit. What is the formula for control limit? Process average plus 3 sigma. Sigma 3.33 means 3 sigma will be 10. So 20 plus 3 sigma will give you 30. This is upper control limit. Similarly, lower control limit is 10 because X bar minus 3 sigma. 20 minus 10 will be 10. Now find out the process width using this formula. Upper control limit minus lower control limit. That is also 20. Specification width is 20. Process width also 20. Now I want to know the capability of my process. So I'm going to overlap the control limit with respect to the specification limit. Let me overlap in the second slide. Now I have overlapped. See here, specification width is 20 minutes. Process width also 20 minutes. It resembles like, the car size and parking area size are almost same. The process looks capable. The process looks capable. See here, process is just capable. Right now it is capable. The car size is exactly equal to the parking area size. But when I park multiple times, when I shift from the center slightly, what will happen? My car will get damaged. My idea was not that great, but it looks great as of now. So this process can be considered as a mere capable process or a just capable process. And the process also resembles a normal distribution. Looking at the data, if you plot a histogram, you will immediately come to know, right? It resembles a normal distribution. And according to normal distribution, 99.73% of your data points will lie inside control limit. 99.73% of the car deliveries will definitely lie inside control limit. Since control limit overlap with the specification limit, 99.73% of your data points will also lie within specification limit. If there are 1,000 deliveries happening in a day, 1,000 bookings happening in a day, 99.73% of the bookings, your car will arrive between 10 minutes and 30 minutes. How am I making this statement? My sample study, I have done it systematically. Without any error, I calculated average, I calculated standard deviation. Now my business is running like this, 1,000 bookings a day, 997 bookings. My car will reach the customer place between 10 minutes and 30 minutes. Maybe three bookings. My car might reach beyond the 10 and 30 minutes. So beyond 30, my customer is going to cancel the order. So if you ask me, whether I'm happy with the business, yes, today I'm happy. But the only risk here is, the situation is resembling like, parking area and car size almost same. Any small mistake will amplify the failure. Right now, the failure is very less, but a small mistake, suppose 10 cars are not coming tomorrow or the drivers are absent tomorrow, few drivers, these are all quite possible. As a result, what will happen? Immediately, the number of failures will be more on the particular day. If you are also concerned about these kind of long-term requirements of the business, you should improvise the process further. As of now, if you ask me what is the sigma level of the process, you need to measure the distance of the process center from the nearest specification limit. The nearest specification limit is this and process center is this. How much is the distance? You can see. How many sigmas are here? 3 sigmas are here. So this process is called a 3 sigma process. A 3 sigma process will assure an yield of 99.73%. How do I say this? Property of normal distribution, rule of probability, right? So 99.73% of the time my car will arrive customer place within the specified timelines, isn't it? And this process is called 3 sigma process. This process is called 3 sigma process, just capable process. However, this capability is true only for the short term. In long term, problems can happen using different ways. Like some challenges will come and play. The variation can increase over long term. So as a result, the number of failures might be more. If the variation increases, what will happen? If the variation increases, control limit will get stretched, isn't it? Because control limit is decided based on the process center as well as the value of the standard deviation. If the variation increases, control limit will get stretched. The spread of the process will increase. As the spread of the process increases, control limit will go beyond specification limit and all your conclusion will go wrong. And that is why it is important to control the variation. So one way I told you how process can go wrong. Variation will increase. Another way is the entire process might get shifted to the right or shifted to the left because of wear and tear of the equipment, because of the absenteeism of the operators, or maybe because of some changes that are possible in any business. So the entire process might get shifted. Let me show you the shifting of the process, and see here. And before going to the shifting of the process, I'm going to give a nickname to the process. If you look at the curve nature, it looks like head of the elephant. So I'm going to call this process as an elephant process. Now you need to understand, you have put an elephant inside a small room. You have put your process within the specification limit, and it is a tight situation. Tight situation means if the process deteriorates, if the process is shifting or deviating slightly, then immediately failures will start happening, right? An elephant cannot stand in a small room for a longer time. Even the small movement of the elephant will damage your walls of the room. So that's why this process is called as just capable process. So in the long term, the damages will be more. And see here, now as of now, the damage is happening or the failures are happening only here. This is why we say the percentage of failure is very small, 0.27. But this is true only in short term. In long term, what happened? Your entire process can shift either to the right or to the left. I'm imagining only the right side, because the left side is safe. Here, this is a one-sided process. When the process shifting to the right, can you now understand your control limit has moved to the right side? See here, your control limit has moved to the right side. Now look at the gap here beyond the specification limit. No, the rejection is not only on the red color area, but also on this white color area. Your rejection has now increased. What you thought as 0.27 is actually has now actually become about 8 to 10%, or it can be more than that, right? Depending on the values of the control limit and specification limit. So a process which is capable in short term becomes incapable in long term. Why? Because in the long term, the variation can increase. Because in a long term, the entire process can get shifted to the right or left. And that is why we need capability higher than 3 sigma. Because even 10% rejection, companies definitely may not be willing to tolerate. So we have to improve the process. There is a clear need for to improve the process beyond 3 sigma capability. And now for the same process, same call center, I have improved the process. How did I improve the process? I have tied up with more number of cars. I have trained all my drivers, isn't it? I have given a GPS system in the car. I have introduced OTP mechanism. There are several improvements I have made. As a result, again, process average is on the target. But look at my standard deviation now. Now I improved it drastically. Earlier it was 3.33. Now it has become 1.66. Now the revised control limit, upper control limit is 25. The lower control limit is 15. Now what happened? Always, every time my customer is booking a car, now I am able to provide the car between 15 minutes and 25 minutes, as against my earlier behavior of between 10 minutes and 30 minutes. Now I minimized the variation. I am not even sending my car too early. I am not sending my car too late. And my customer specification is up to 30 minutes. But I always make sure all the time my car reaches the customer place within 25 minutes. So now I am very sure that between 15 minutes and 25 minutes, 99.73% of the deliveries will happen. If within control limit, this much percentage can happen, what will be the percentage between specification limits? More than 99.73, isn't it? That means my process has become much more capable now. If you actually look at the size of the process, my process has now become doubly capable. How do I say doubly capable? Look at the specification width, 20. Look at the process width, just 10. Imagine you give your child 20 rupees packet money, but your child is spending only 10 rupees and put the remaining 10 minutes in savings. And definitely this savings will help your child in a challenging scenario. That is what you are doing in the business also. Customer has given you a wider tolerance. You are using only half of the tolerance. Even if something goes wrong, the remaining tolerance which you saved will definitely save you. And that's how you make your process 100% failure free, close to 100% failure free. And definitely all your products and services will be defect free in the hands of the customer, right? Even if your process shift, even if your process shift or drift, the rejections will still be very, very lower. If you ask me the sigma level of the process, look here, the process center is here, specification limit is here. What will be the distance between process center and specification limit? There are 6 sigmas you can see, because control limit stays at 3 sigma, and the entire gap is actually how much it is. Yeah, 10 on the right side, and up to this is 5. So this will be remaining 5. That means there are 6 sigmas between process center and the nearest spec. This process is called 6 sigma process. This process is called 6 sigma process. That means the capability is doubled. Under such situation, even if your process, we are going to call this process as giraffe process. Why the name giraffe? When you push the control limit, when you reduce the variation, you can see control limit getting pushed inside. When the control limit pushed inside, the curve will become narrower. The curve will not only become narrower, it will also become taller in the center. And that's why, just to remember the concept, I'm saying that you converted the elephant into a giraffe. So seeing the narrower curve, seeing a taller curve means your process capability has become higher and higher. And now see here, my process is shifting. Statistically, it is estimated that the process will shift by an amount equal to 1.5 sigma. So this process, when it shifts, see here, look at the position of the control limit. The control limit move by an amount equal to 1.5 sigma. In whatever capability you see in the short term, will be higher than the long-term capability. That means the long-term capability will be lower than the short-term capability. Why it is getting lowered? The control limit will shift by an amount equal to 1.5 sigma. But even after the shifting of the control limit, still you have some more tolerance. Even if your car gets delivered beyond the control limit, it is only an internal failure. It becomes objectionable only for your business. Customer will still accept, right? But however, every time a point is going beyond control limit, we will consider that as a special cause. We'll react to it. We'll question ourselves, how come a delivery can happen beyond control limit? So what went wrong? We'll immediately correct our process, and thereby we can prevent the future failures, right? And this process is called the 6 sigma process. And now the success rate will be definitely higher than 99.73. It is 99.999%. 99.999%. And look here, the failure is happening in this manner. Even though the failure is represented by red color, only a small portion of the red color area will get noticed by the customer. And that's how 6 sigma is assuring you a result of close to 100%. If at all there are any failures, that will be limited to just 3.4 dpmo. What is that 3.4 dpmo? The small portion of the red color area extending beyond the specification limit. This is 3.4 dpmo. This is how 6 sigma capability delivers results close to 100%. Delivers defect-free products and defect-free services. And now you can try answering this question. And see here, there is a curve.